40% fill rule restricts the overall cross-sectional area of cables to 40% of the total cross-sectional area of the conduit or pipe. To figure out the maximum number of cables you can put in, you need to know the cross-sectional area of both the cables and the pipe. Let's start by figuring out the cross-sectional area of a Cat-5 cable. A standard Cat-5 cable has an outer diameter of about 4.7 mm. To find the cross-sectional area, we use the formula area equals pi times radius squared. The radius is half the diameter, so in this case it's 2.35 mm. Plugging that in, we get area of cable equals pi times 2.35 mm squared, which is about 17 mm squared. Next, we need to determine the cross-sectional area of the pipe. Pipe size is usually given by its inner diameter. For example, a 1-inch pipe has an inner diameter of about 25.4 mm. To find the cross-sectional area of the pipe, we use the same formula area equals pi times radius squared. In this case, the radius is half of 25.4 mm, which is 12.7 mm. So, the area of the pipe equals pi times 12.7 mm squared, which is about 507 mm squared. Now, we can use the 40% fill rule to find out how many cables can fit. The formula is 0.4 times the area of the pipe equals n times the area of the cable, where n is the maximum number of cables. To solve for n, we divide both sides by the area of the cable. So n equals 0.4 times the area of the pipe divided by the area of the cable. Plugging in the values, we get n equals 0.4 times 507 mm squared divided by 17 mm squared, which is about 12. Therefore, you can pull approximately 12 Cat-5 cables through a 1-inch pipe while staying within the 40% fill limit. Firstly, ensure you always consult local and national electrical codes for the most accurate and up-to-date regulations, as these can vary. Secondly, remember that this calculation provides an estimate. Cable manufacturers may have slightly different outer diameters for their Cat-5 cables, so always check the specifications for the specific cable you are using to get the most accurate result. Thirdly, consider directing factors if you are bundling multiple cables together. Bundled cables can generate more heat, which may require you to reduce the allowable ampacity of the conductors. Consult the relevant tables in the NEC or other applicable electrical codes for directing factors. Fourthly, when pulling cables through conduit, use cable pulling lubricants to reduce friction. This makes the pulling process easier and reduces the risk of damaging the cables. Fifthly, avoid exceeding the maximum pulling tension for Cat-5 cables. Excessive tension can damage the conductors and affect the cable's performance. Refer to the cable manufacturer's specifications for the maximum pulling tension. Sixthly, ensure that the conduit is properly supported and secured. Loose or poorly supported conduit can sag or become damaged, which can put stress on the cables inside. Seventhly, use proper cable management techniques to organize and support the cables within the conduit. This helps to prevent tangling and makes it easier to add or remove cables in the future. Eighthly, consider using cable ties or straps to bundle the cables together at regular intervals. This helps to keep the cables organized and prevents them from spreading out and taking up more space in the conduit. Ninthly, when making bends in the conduit, use the correct bending radius to avoid damaging the cables. The minimum bending radius is typically specified in the electrical code or by the conduit manufacturer. Tenthly, always visually inspect the cables after pulling them through the conduit to ensure that they have not been damaged. Look for any signs of cuts, abrasions, or kinks in the cable jacket. Keep in mind that the calculation is based on a straight conduit run. Bends and offsets in the conduit will reduce the allowable fill capacity. For bends, it's best practice to reduce the number of cables you pull to ensure easy installation and avoid damaging the cables. Also, the type of conduit you're using matters. Different conduit materials, such as PVC or rigid metal conduit, have different inner diameters for the same nominal size. Always refer to the manufacturer's specifications for the actual inner diameter of the conduit you are using. Remember to consider future needs. If you think you might need to add more cables in the future, it's a good idea to leave some extra space in the conduit. This will make it easier to add cables later without having to replace the conduit. Also, make sure to use the correct size of pulling rope or fish tape for the size and weight of the cables you are pulling. Using too small of a rope or fish tape can cause it to break, which can be a major hassle. Always follow safe work practices when pulling cables through conduit. Wear appropriate personal protective equipment such as gloves and eye protection, and be aware of your surroundings. Remember that the 40% fill rule is a maximum limit. It's often better to stay below the maximum fill to make it easier to pull the cables and reduce the risk of damage. The 40% fill rule generally applies to 3 or more conductors in a conduit. For a single conductor or 2 conductors, the allowable fill percentage is higher. Consult the NEC or other applicable electrical codes for the specific fill percentages for different numbers of conductors. Additionally, the 40% fill rule is based on the assumption that the cables are all the same size. If you are pulling cables of different sizes, you will need to calculate the total cross-sectional area of all the cables and compare that to the 40% fill limit. It's crucial to use properly sized connectors and fittings for the conduit and cables you are using. Using undersized or incompatible connectors can create a fire hazard. Always torque connectors to the manufacturer's specifications to ensure a secure connection. Over-tightening can damage the connector, while under-tightening can lead to a loose connection. Remember that communication cables like Cat-5 should be kept separate from power cables to prevent interference. If you must run communication cables and power cables in the same conduit, use a divider to separate them. Always check with the local authority having jurisdiction, OJ, for any specific requirements or interpretations of the electrical code. The AHJ has the final say on whether an installation is compliant. Consider the environment in which the conduit is installed. If the conduit is exposed to direct sunlight, it may be necessary to use a conduit material that is resistant to ultraviolet radiation. If the conduit is installed in a corrosive environment, use a conduit material that is resistant to corrosion. When pulling cables through long conduit runs, consider using intermediate pull boxes to reduce the pulling tension. Pull boxes allow you to break up the long run into shorter sections, making it easier to pull the cables. Always seal the ends of the conduit to prevent moisture and debris from entering. Moisture can damage the cables and debris can clog the conduit. Make sure to properly ground the conduit system according to the requirements of the electrical code. Grounding helps to protect against electrical shock hazards. When working with electrical systems, always de-energize the circuit before starting work. Use a voltage tester to verify that the circuit is de-energized. If you are not comfortable working with electrical systems, hire a qualified electrician to do the work. Incorrectly installed electrical systems can be dangerous and can create a fire hazard. Finally, double-check all of your calculations and measurements before starting the installation. A small mistake can lead to big problems down the road. Always remember that safety is the top priority when working with electrical systems. Take your time, follow the instructions, and don't be afraid to ask for help if you need it. It is highly recommended to consult with qualified electricians and refer to the NEC or local electrical codes for specific requirements and guidelines related to cable installations and conduit. These resources provide comprehensive information and ensure compliance with safety standards and regulations. Additionally, consider factors such as cable weight, pulling angles, and conduit fill capacity to optimize cable installations and prevent damage or performance issues. Remember, the 40% fill rule is a guideline to help ensure proper airflow and prevent overheating of the cables within the conduit. Overfilling the conduit can lead to reduced cable lifespan and potential safety hazards. Always prioritize safety and compliance when working with electrical systems.